Hey everybody, this is Larry. This is day 24. Yay. Happy holidays. Of the Leetcode December daily challenge. Hit the like button, hit the subscribe button, join me on Discord. I do usually explain and solve and go through my thought process live. So if you want to just see the solution, maybe fast forward or watch another video. Let me know what you think. And yeah, did I always say hit the like button, subscribe button, and join me on Discord? I don't know. I say a lot of things nowadays. But yeah, okay, let's see. Today's problem: swap nodes and pairs. Given a linked list, okay. So I think in general, linked list problems they only come up on interview for the most part, and definitely something to practice for that reason. But I think conceptually, I don't think there's anything that difficult conceptually. You just have to really trace what you're doing, right? Like you just have to talk to yourself through different edge cases and so forth, and experience and practice will allow you to, and maybe even reading code allow you to implement it in a way that has fewer edge cases, sometimes shorter code as well. So okay, with all that being said, let's take a look. So we have a head node, and we just have to swap pairs. Yeah, so then my idea would be that maybe I have I have a pointer that goes, that goes 2 nodes at a time, and then for every time I swap the last 2, something like that. That's the way that I would think about it. The little bit, I'm also just double checking how they do, like, return the head, but I guess you just return the node. Okay. So one thing that I've been actually recently picked up, which I don't know, your mileage may vary. Let's just call it old head. Is that I've been creating a seno value, a seno head, so that it makes things easier, because then now I have a pointer to the first node instead of doing weird things that like if you have to modify the pointers to the head, then you don't have to have more edge cases. Now I just have a linked list where you just ignore the first node, and the first node is actually head.next. So that's one thing that I've been doing, just picking up by doing a lot of practice. So there's no something. So okay, so now as we said, so we have a pointer that moves every 2 nodes. So this is always even number of nodes. No, so we might have to take we definitely, if the odd number of nodes, we definitely have to take care of it. So okay, so let's just have a current node, and this is the one that goes 2 nodes at a time. So let's do that. Node is equal to head, say. Yeah, okay. And then while head is not none, we do this thing. So then now at the very end, we want to move current 2 nodes. So in theory, what you want to do is write something like something like this, but current.next can be none. So that's why I'm going to leave a comment here so that I make sure. Let me actually make sure to check current.next is not none. I guess I could have just added if statement. Okay, so we could just do if. Okay, fine. Let me just write it then. While we're here, current equal to next. If current is not none, current is equal to current.next. So if current is none here, then this would end the loop anyway. So this should be okay, moving it 2 nodes. So then now, before that, we want to get next node, say next node. Let me actually also have consistent casing. Next node is equal to current.next. Next node is equal to current.next.next, and again we have to make sure that this is not whatever, right? So actually we can check that real quick. If next node is none, then we just break, right? Because that means that this is going to be bad. And also while we're at it, I guess we'll just set to this, even though they're about the same, slightly faster, I suppose. And then now we want to swap the nodes, right? Okay. So then we have to have the node that points to current. So then so this is where also it makes it easier as well. Now current already is the previous node, so that should be good actually. Or like the current points to the node that we want to swap, and next node points to the node. So next node and current.next is the next node. Oh man, the language is bad. But basically, we want to swap next node and next node. So let's see. Okay. So how do we want to do it, right? And this is just visualizing and make sure that the order that we swap is good. So basically, okay. So basically, we want next node dot next is equal to next dot next, because now we want next node to point to after that, and you should draw it out obviously. If you're at home, I'm a little bit. It's hard. I don't have a pen thingy, so. But yeah, but this obviously gets rid of next node dot next, which we need. So, well, actually, it already. This is already next node is already next node dot next, right? Yeah. So then now, next node dot next is equal to next node, right? Is that good enough? And then at the very end, we can return head.next. I feel like I'm missing something, but none type has. I thought we checked for that. Line 18. Oh, I guess this could be next as none as well. If next node, oh yeah, if next node is none, then we also want to break, because then we don't swap, because then that's the odd number case. Well, we're close. Not really, actually. We're just wrong in a couple of places as well. So then now we have to think a little bit about what's going on. Oh, we don't update current. That's the one thing that I missed. So current.next is equal to next node. Yeah. Where current is kind of the previous node, right? Okay, so there we go. I feel like I missed something, but again, you just have to kind of, what I would recommend doing is at home, maybe draw it with different colors and then make sure that each of those things get updated. And if it wasn't for the fact that I'm doing it at 3 a.m., I might be a little bit more inclined to do so. But yeah, and I apologize for that. Let's try odd number as well. I mean, this is pretty much the same, so let's run it real quick. Oh, whoops. I mean, I'm just banging on the keyboard, so I don't even think that was a thing, but okay, let's run the code again. Does that look good? Yeah, it looks good, so let's give it a submit. Cool. That's really all I have for this problem, except for the complexity. I don't know why I always say it that way, but yeah, I don't think, I mean, I think this is straightforward in terms of complexity. We go through we look at each node multiple times, but constant number of times as we do the swaps and look at nexus and stuff like that and do a lot of dancing. And in terms of space, well, we don't really create anything other than, in my case, a new head node. Yeah, we modified the current next, so that's pretty much going to be constant extra space. So yeah, I think that's okay. I mean, I don't know if this. I mean, I don't think you need to do this recursively or anything, because that would actually take more space. But yeah, so linear time, constant space. Let me know what you think. Again, happy holidays, everybody. Hope I'll see you later. Bye bye.